Okay, this is going to be a calculator active problem, so you can use the calculator to evaluate everything. Part A asked you to find the region of area R, so that's just this little region right here. Notice this graph is there's only really one main function here. It's this one, y equals e to the 2x minus x squared, and then your only other two functions are the horizontal line y equals 2. And then we've also got this horizontal line, y equals 1. Okay, so part A just asks you to find the area of R, which is that blue region that we have up here. So notice if I draw my rectangle, it's always going to be the black minus the 2. So I only need one integral, and we're talking about area, so I just need to find the area of that one rectangle. So it's just going to be the height of the function, which is 2x minus x squared. So that's the top of this rectangle. The bottom stops at 2, so minus 2. Remember, top minus bottom. That's the height of the rectangle. The width of this rectangle is dx. So that's the area of one rectangle. If I want to find the total area, we're going to integrate. And I need to integrate from here, where the shaded region starts, to here, where the shaded region stops. And this you could use on your you can find the intersection points on the calculator. I'm going to call this one Q. And I'll store it on my calculator, but this is what that value is. And then this value I'll call P, and store this on your calculator as well. So then I can just use these numbers all the time. I think this is a 7 here. So I'm going to integrate from P to Q. And if you type this into your calculator to 3 decimals, it's 0.514. Okay. Part B, let's see, let me get rid of this now. Okay. Asks you to find the area of region S. So notice region S is just this area right here. Okay, now we can do this a couple ways. The way I'm going to do it is I notice that if you actually find the area of all of this, notice, and I draw my rectangle. If I integrate from this time, the entire shaded region starts here and ends here. So this is exactly 0, this is exactly 2, and you can check on the calculator if you need to. So if I integrate the whole shaded region that includes both R and S, so there's my rectangle, the top is the function, notice the bottom goes all the way to 1. So that will give me all of this blue shaded region, but all I want is S. So notice though, if I subtract off the R, so if you think of it like this, if I take all of this, but then subtract off just the R piece, notice you'll be left with S, which is what I'm looking for. So that's how I'm going to do this problem. I'm going to subtract off the area of R, but that's what we came up from part A. And this you can type into your calculator. It ends up being 1.5416. The other way you can do this problem is, if you look at region S, which is what they're asking us to look at, let me sketch this. So region S is this region here. If you just draw a rectangle of that region, here, notice it's 2 minus 1. But then if you go over here, notice it's the red function to 1, and then over on this little piece, it's also the red function to 1. So you would need a couple different integrals. So you could split it up here at P and Q, find the area of this piece, do that one separately, do the area of that middle square, do that one separately, and then do this little piece separately. So you could add the 3 separate pieces together and you would get the same answer. Okay, last piece is talking about volume. So it says, write but do not evaluate an integral expression that gives the volume of the solid generated when R, so we're only talking about region R, is rotated about the horizontal line y equals 1. So we only care about this region R, and we're going to go ahead and rotate about y equals 1. Okay, so we are rotating and we're using volume. So remember, we have to be perpendicular to your axis of revolution. So since we're going about y equals 1, to be perpendicular, we have to use dx. So make sure you figure that out first. Now, Your bounds you can figure out because we're only looking at this shaded region. So your bounds are just going to be the bounds of that shaded region. It doesn't matter what you're revolving about. So if you want to set up the bounds, you could do that as well. So we've got volume. I know my bounds are going to go from P to Q. And notice I do have a big gap between my shaded region and my axis of revolution, y equals 1 here. So I should be thinking pi big R squared minus little r squared. So this is what I'm trying to figure out. So let me actually do this in a different color so we can see the... Okay. So your big R, remember, you want to touch your axis of revolution. You want to, oops. You want to touch your sorry about that. You want to touch your axis of revolution, cover the shaded region, and you want to go all the way up to the function. So this is going to be your big R. Your little r is going to be just the whole, which is the non-shaded region. So that's your little r. So look at your big R. It's the top minus the bottom always. So the top of big R is the function. So it's e to the 2x minus x squared. The bottom goes to 1, so minus 1. This is your big R squared. Minus, look at little r. The top of little r is just 2. The bottom of little r is 1. So there's your big R squared minus little r squared all times dx.